primarily developed for the glass industry, but I feel there's a wide range of applications for this. It starts at 600 C, which is 1112 degrees F, and it goes up to 1800 C, so it's about 3200 F. And it's a low-cost fiber optic. So for this, it's something like $2,200 US dollars with the fiber optic and with the electronics box. This is a 420 loop-powered device, so it's simple to wire. It does not have any focusable laser, so it doesn't focus. But the spot size, I think this is about 100 to 1 field of view on this one as well. Generally, in the glass industry, you put it on top of the furnaces, the four hearths, and you mount it with an air purge, and stainless steel air purge and cooling. And this is used for the glass, but also could be used for metals. Because it's a short wavelength, it's a 1 micron. So anything under 3 microns is going to be good for metals. We can also configure this. This has a test device which I could provide you. You can switch it over. You can create a 20 milliamp or a 4 milliamp output or 12 milliamp. So it creates like a source as well. And you know, the connections, as you'll see, you just unscrew it. This is a glass fiber inside of this stainless steel sheath.
So it's still a single core fiber?
Single core fiber, yeah. So you have one glass fiber inside of here. And then your lens is the same thing. It just, you unscrew the fiber. If you need to, here's the lens assembly. So this is a low-cost fiber optic series. If you need fiber optics, you have to go low-cost. Unfortunately, there's 600 to 1800 C. That's the only temperature range that comes available with this low-cost sensor. The DSF-30, I call it PSC-30 series. 30NG. PSC-30NG. And it'll be the next slide here. Basically, what that does is adapt the lens to a target tube. Whenever you look inside, remember I mentioned earlier, if we look inside a crevice or a hole, your emissivity goes up 3 foot, 5 foot, whatever target tube, but it's closed-ended at the end. I don't care if it's aluminum, the target tube. The reflections in the emission cannot escape. So you're capturing many more than 8 reflections. Your emissivity is going at 99%, 100, almost 100%. So it doesn't matter what type of material. In there, Corey, you'd have to, they're generally used for high temperature applications. Because we'll put the target tube into the hot zone. We'll have a closed end. And then we'll just look down at the bottom of the target tube and we'll measure what the temperature is. So the emissivity is excellent. Therefore, you know, the repeatability and stability of the system will be great. You could either purge it as well. You could even put a window in the front. In target tubes, here's the PSC-30. I made this specifically for innovative low-cost solution for replacement of high temperature thermocouple. There's no reason you're going to buy a $2,100 device or $2,200, whatever, and maybe with an air purge another $400 or $500. Pay, you know, the 2,000 range to replace a thermocouple, unless you're in a hydrogen environment. Hydrogen molecules get into the well, thermal well, because they're permeable and they degrade the thermocouple, or it's a high temperature, where thermocouples will only last 3 to 6 months. You know, we're looking at 3,000 degrees Celsius, or 2,500 Celsius, 1,700 Celsius here. Because the flat ones generally go up to, we were using 1,700 degrees Celsius for some black body calibration switches. So this is a good way to get a good measurement, stable measurement, and a thermocouple. If you're paying a platinum thermocouple $1,000 or $1,200, and this lasts, say, 10 years, you know your payback is going to be, you know, 20-fold. And not just the payback on the thermocouple, the payback on the installation. Somebody has to go out there, pull out the thermocouple, replace the thermocouple, and here you don't have to worry about that. You get a 40-20 milliamp signal, which is very strong. And so there's all different types of thermal wells that can be adapted. As I mentioned, this is 600 to 1,800 degrees C. That's the highest temperature range right now. I think we're going to be able to increase that temperature range.
Use their existing well, right? Even if it stays
that's because of all those requirements.
whatever the well is. Now, all you need to worry about the aperture on this thing.
Okay.
It has no, let's say it has no aperture. We'll say if that lens is a ½ inch, you've got to have a minimum of a ½ inch ID, because then that gives you no leeway to go left or no error. So, you know, if that's a ½ inch, and you can look on the charts, it'll tell you. I think it's a ½ inch lens. It might even be 0.35 inch lens. Your target should be, you know, at least 50% bigger in the hole, so it can clear that. It doesn't hit the beginning of the target tube. But this is a 100 to 1 field of view, so we've used it. You know, I've used it in the glass industry, where you actually put platinum, like platinum wells in the glass, but in the sintering applications where they had carbon tubes, graphitizing, and applications where thermocouples just don't survive. Now, this is not a solution for the thermal well. If you have an abrasive material and you got the thermal well in there, and the thermal well is still going to break, that's the target tube. This is a solution for when the thermocouple fails because of the high temperatures, and they don't last that long. So here we have sulfur recovery furnaces, reheat furnaces, incinerators, garbage incinerators, heat treating furnaces, vacuum applications, salt baths, glass melt tanks. Here you can actually see that was on top of a glass furnace there, or floor hearth. Here is the air purge assemblies that are made out of stainless steel. There's a little bayonet connection here. Put the lens in, screws in, bayonet screws in, and it actually pushed down, and turns it, and it locks in place. So the fiber optic cable will come out from here. The lens is going to be in this area here. And then there's an air purge. If you want to use an air purge on a closed-in system, well, you can pressurize it, put a pressure switch. So if the tube breaks, somebody will be alarmed and say, hey, the target tube broke, so let's make a change. Or if they have to, on some occasions, what they'll do is they'll put a small little hole in here, and when they purge it, it just evacuates any debris that's in the tube. What happens in the target tubes, specifically with ceramics, you know, graphite, when they fabricate the products, they're actually putting a bonding material in there. So like a glue. And what happens is when you put it in high temperature, it outgasses. So we looked at an experiment that heated up this tube, and I looked inside and I see smoke generating binders out. And that happens within like 24 hours, maybe 36 hours. So if you were to install this, what we ask is, generally speaking, you could install it right away, but over the next 2 days, pull out the lens and clean the lens and make sure the lens is clean. Or put in the tube and let it bake out for 24 hours. And then it doesn't outgas any longer. So that's the only thing. So in some instances, the customer will want to put a small little hole here, and then he purges it, and then any of that smoke that's generated during the outgases will escape the closed-end target tube. So that's basically a black body condition there, 100% emissivity, no matter what type of material it is, because it's a closed-end target tube.